Welcome everyone, my name is Maitrish. I am going to give a brief seminar about the topic joint probability distribution function. So let us see what it is. So in joint probability distribution function is nothing but differentiation of joint distribution function. Let us see the what joint distribution function. It is given as double integral of minus infinity to infinity small f x y x comma y dx and dy. This is known as the joint distribution function. If we differentiate it, we will get joint probability density function. For continuous system, we will use minus infinity to infinity. For discrete systems, we will use 1 to n. So let us see the properties. The properties of joint density function begin with the property of non-negativity. So in simple terms, as we know, the probability of any function is less than 1 and greater than 0 or greater than equal to 0. So we will use the same condition here. So let us assume this interval for multiple functions and we will get this one, that is probability of x less than equal to x comma y less than equal to x. This is the normal probability for multiple random variables. So we will take x and y as two random variables, that is capital X and capital Y. So if we apply the limits of probability, we will get this. If we double integrate this with respect to x and y, we will get this as shown in here. So we will take this small probability for whole thing. Henceforth we will get the condition of non-negativity. Hence first property is proved. Let us proceed. So second property is total probability is equal to 1. So as we know, the area under graph of a probability density function is equal to 0. Same condition applies to this. The joint density, or in simple terms is given as the given sum of all joint probabilities of x to y over an entire space of given action is total probability equal to 1. In simple terms, what it says is the probabilities of all outcomes or the average of sum of all outcomes is equal to 1. That is what going on here. So let us proceed with the next property, that is the joint distribution function, and this property states that what is joint density function directly. This, so we have to prove that this from direct integration, that is we know the double integral something. Here we have it. So we will double integrate with x and y with 2 and we ask with the respect to of x and y random variables. Then first we integrate with respect to y and we will get this, and if we integrate this we will get integral minus infinity to infinity dou fx y of u comma y into dy du dv is equal to fx x comma y. So that's it. That's what we required. If we reverse reciprocate with respect to x from the starting, we will get the integral in minus infinity to y and df dy x comma v derivative of v into dv is equal to f x comma y. Same happens in case of y x also. So let us go to the next property, that is probability of joint event. What is the probability of joint event? Here we have been given the probability of x random variable is in between x1 and it's less than or equal to x2. Same conditions for probability of random variable y. So if we integral it in intervals given, we will get this. So we have to prove, and there are also some other conditions like this. So let us see the proof of this thing. So let us see, as we know, the probability of a joint event in between interval is given as like this, that is probability of x less than y minus probability of x less than or s less than or equal to x1 in union with probability of y less than equal to y2 minus probability of y less than equal to y1. So remove if you consider it as a whole and apply the set functions, we will get this, and if we apply the integrals according to the initial properties, we will get directly this. So let us see it in clear way. Here we will get the integrals to minus infinity to x2, and whole it will be whole integrated with the inner terms like this. So after whole integral, we will have to go to the next step, same to the minus part of x2 like this. So here we will do once with x2 and we will get one time with x1. So we will apply all integral minus infinity to x1 and minus to x2. So next step we have to do is inner calculations. So if we do this thing, it will be minus infinity to x2 minus infinity to x2 y2 x comma y dx comma y dy minus this. So after waiting, two terms become 0, that is after the cancellation of the 0 terms we will get this. So if we observe these terms carefully, we can observe that it is minus infinity to x2 and minus infinity to x1 and minus 1 to y2 and y1 to y2. We can observe this change. Henceforth, we can directly write it as this. So minus infinity to minus infinity will become a path, like the x1 and x2 are in between minus infinity to infinity. So we will get it as x2 to x1 and y1 to y2 fx of x dx dy. So let us see to the next property, that is marginal distribution. Marginal distribution is nothing but finding random distributions with respect to only one variable, or conversion of joint random distributions to single random variable. So for getting a random variable with respect to x, we will do the integration with minus infinity to x minus infinity to infinity with dx and dy. In simple terms, we have to integrate it with minus infinity dx, and simple with y, we have to integrate it minus infinity to y dx dy. So marginal distribution function is a simple property that we have to do this verification property. Now how we verify? Let us assume y is equal to minus infinity, and if we do this, we will get the probability density function. We do minus infinity to y interval, we will get integral minus infinity to x f x comma dx. This is the probability joint distribution function. So next, similarly to joint distribution we will do the same and we will get the marginal distribution function with respect to y. So let us proceed forward, and the marginal density function of x comma y. Previously we seen marginal distribution function, now we will see marginal density function. So how we will get? Simply we have to calculate the marginal distribution function and we derivate it with. So let us see from fifth property. Let us consider a marginal distribution function and we derivate it with respect to x to get marginal density function, and we will get the derivative like this, and if we differentiate we will get to dou f x comma y is infinity for integral and x. Henceforth we will get the marginal density function. So similarly, if we do the random variable y, we get this, that is fx comma y minus infinity to y minus infinity to x comma y x comma y dx dy. So henceforth, if similar to the above we done for x, we will get for y. So let us proceed forward. Thank you for your support, and let us give a brief revision about the properties we learned today. So first property we learned today is the property of non-negativity. So let me note property of non-negativity. In similar terms, we can write it as fx comma y less than or equal to 0. Next property we learned is the probability over the total probability of is equal to 0, that is minus infinity to infinity, or double minus infinity but double integral minus infinity to infinity small x comma y dx dy is equal to 1. So the next thing we have learned is joint distribution function. In joint distribution function, the integral of minus infinity to x and minus infinity to y fx comma y x y dx dy is the joint probability distribution function. Next property, the fourth property we learned is the probability of joint event. So let us consider an event x1 and x2 and y1 and y2. Further, we apply the event conditions like this, and if we have to prove that the events of probability density, probability joint probability, joint events is equal to, can be represented as this in continuous. So let us see what it is. That is p of x less than equal x1 less than equal to x less than equal to x2 comma y1 less than y less than equal to y2 is equal to integral minus x1 to integral x1 to x2 integral like y1 to y2 is fx comma y dx dy. So let us proceed forward with another, that is marginal density function. For marginal density function, we have to do integral with respect to opposite value of what we have to need. So if we want x, we have to do integral and integration with respect to y. If we want y, we have to do integration with respect to x. So what is the this is the proof, and last but not the least, we have is marginal density function. So for the marginal density function, we have to first calculate marginal distribution function. After calculating the marginal distribution function, we have to integrate or differentiate it with respect to the given value what we need. So for after we get the marginal distribution function, we have to derive it with respect to y to get the marginal density function of y, or vice versa for x. So thank you, and similarly for this, and thank you. I hope you learned something new. Have a good day.